Welcome back everybody to another snake enclosure automation project. This might be the last video in this series. We'll just have to see if we get everything covered. But in this video specifically, we build a case to hold all of the electronics so that they're not just willy-nilly all over. We also rewrite the entire program because we ran into some issues that we'll talk about when we get to that part of the video. And we also had some hardware improvements. So let's get into it. So this is a time lapse of me using SolidWorks to 3D design a enclosure for the electronics to sit in. I've got individual slots for the Arduino, the breadboard, and then at the end I have got a slot for the relays. During this process I had to guess on some of the dimensions. Some of the holes were difficult to measure on the Arduino, and making sure that there was enough clearance for the wires to pass through. Now, since we've got the 3D model finished in SolidWorks, we're over to the Bamboo Labs P1S printer doing the time lapse from the integrated camera. This part is one half of the bottom where the electronics actually fit into. This is the relay side. The big slit there in the bottom is where the wires will all pass through out to the heat lamps. This one is the time lapse of the other side. So this is the side that holds the Arduino and the breadboard. The breadboard part was actually had to be cut in half, so half of it is on this side, the other half is on the other. But the hole on this side that we can see here is where the mains power will come into the Arduino, and also the wire for the serial monitor if we need to use that. This one is one half of the lid. These prints were a lot faster than the others, but this is the left side of the lid that goes over top of the Arduino, and this is the right half of the lid that goes over top of the relays. There's really no difference on the sides, but I just wanted to show both. So with the prints complete, this is the side that holds the Arduino. The Arduino just slides in there, and you can see that connected over to the breadboard on the right of the screen with the clock module on the top of that. This was one of the dimensions that I had to guess on, and unfortunately I guessed a little bit too low, so I had to cut out some of the piece to make it so the Arduino could fit and the wires could fit in there without getting pinched on by the print, but it worked out okay. And this is the slot where the mains power goes and gets fed into the relays, so each one of the heat lamps goes into its corresponding relay on the inside of that, and this slit here is where the wires can pass through to the outside of the box. Here it is all assembled. All of the electronics fit nicely in the box. I was happy with the build and the dimensions overall, and you can see it connected to that external LCD display. This is a video of the system working, the LCD display showing that we're initializing, testing those relays, and then we go to day control with the temperature displayed on the bottom. We'll go over all of the things that it displays in the code section coming up next. So the code has gotten completely out of hand. So this is a time-lapse video of me rewriting the entire code. Turns out that when you're writing something, it's not the best practice to start writing something and then add function and add function and add function. It just adds complexity and more likely chances of messing up and getting into loops that are with unintended consequences. It took me about an hour to get the code completely rewritten, but I like it a lot better now. I changed some of the functionality and I added some additional failure modes, but in a much more streamlined process that keeps us out of loops that we didn't want to be in. And unlike Boeing, I wanted to do some testing. So here we have the testing. We're starting from an off position, so you see the relays testing on and off, making sure that those are going to work. And then we go to day control and it starts reading the temperature. And in this test, we've got low temperature, which gives us all 3 lights on, which is working absolutely perfectly. So the next thing to test is going to be in day control loop when we're cooling down from just below the maximum enclosure temperature down to below 82, where we start heating back up with both of the heat lamps. So when we hit that threshold of less than 82, we delay doing anything else in the program for 3 minutes, and this is to prevent rapid switching for hanging out on the border between 82 and 83. If it starts to heat up to 83, it would shut off, and then we cool down to 82, and then it would turn on, and we end up getting rapid relay switches. I had handled this in the previous code with a while less than 90 condition, but it got really messy, and this is the loop that I unintentionally got stuck in, and I needed to rewrite the entire program to solve this issue. So you can see that both lights turned on there and it's functioning as planned. And this is a test where we're coming up from a low temperature state into a 2-lamp heating state. So you can see the temperature climbing slowly. We're at 74, and then we'll go to 75, and we'll hit the third lamp off. There we go, and now you can see the third lamp in the background turned off, so now we're just heating up with 2 lamps. And I'm going to wrap it up with a temperature probe failure test. So here I just unplug the temperature sensor, and you'll see that it goes to temp fail mode, and the red light turns on, and then I plug it back in, and it comes back, and we go back to day mode. So that's it for this video. We made a lot of improvements, completely rewrote the code, made it more robust, made it easier to follow, made sure we didn't have any unintentional loops that we could get stuck in. We constructed a case for the electronics. We added the LCD display that tells us the mode that we're in, the temperature, and the humidity. And we improved our failure modes, and we did a bunch of testing. So like, comment, and subscribe. It helps a ton for a small YouTube channel like mine. If you come across it, even just leaving a comment saying, I hated it, that works because it's engagement. So I will see you in the next video.